Oh, just you. Great. So got Fiona ready to roll from Detactics, which I've learned how to say. Thank you. So yeah, thank you.
We'll try. Second go. Oh, can everybody hear me now? Yes. Super, super. So hello, and thank you very much to Women Tech Makers for having us today. My name's Fiona, and I head up the software development and the machine learning teams at Detactics. And today I'm going to talk about machine learning in terms of moving from experimentation to production. And there's going to be a couple of diversions along the way, so it'll make sense as we get into it. So a brief overview. I'm going to talk about Detactics, who we are and what we do, and then jump into the ML side of the presentation. So highlight what machine learning is, the concept of technical debt in machine learning, and a life cycle of a machine learning process as well. And then at the end, I'm going to finish up with some practical demonstrations of how we have implemented machine learning into our technology process in areas such as profiling data and matching data. Okay. So Detactics, we are a 70-person firm based here in Belfast. We are located over at beside the Waterfront Hall, and we specialise in data quality and matching at scale. So we've built a platform, and this enables our clients to perform matching of their data, to perform data quality on their data, to report on their data assets, and to fix their data assets. And we've primarily focused in the financial and governmental sectors, and the slide here highlights some of our clients. And the type of work that we do, so we help our clients with their data quality by providing self-service data quality. So business users and experts can manage and fix their own data. We also help with tasks such as providing single client views of data, entity resolution, and also semantic analysis, which my colleague Fiona is going to talk about later on today. Okay, so now into the machine learning part of the presentation. So I thought I'd start by distinguishing between artificial intelligence and machine learning. So we often hear these two names and concepts used interchangeably. Now, interestingly, there's no agreed upon term as to what AI actually is, but here goes. So AI is generally considered the capability of a computer program to perform cognitive tasks, which we would usually attribute to a human. So things like being able to problem solve, being able to translate between different languages, being able to identify patterns, and so on. And machine learning is a subset of artificial intelligence. It involves the different algorithms and statistical models. These models are fed with data, with examples of something that you're trying to predict. They learn patterns from this underlying data, and they use this knowledge to then make predictions on new data or distinguish between outcomes. And we've got different flavors of machine learning. So we've got supervised machine learning models, we've got unsupervised machine learning models, we've got reinforcement models, we've got semi-supervised machine learning models. But in the context of time, I'll not jump into all of them. So this slide here, it highlights the artificial intelligence umbrella, the different tenets of that, and also highlights the plethora of machine learning models that we have and that we can use. And we've got lots of different areas from neural networks, so you may have heard of deep learning models. We have other areas such as trees, so like decision trees and random forests. We have different types of clustering methods such as hierarchical clustering. We have other areas which are based on probabilities, so things like naive Bayesian approaches and so on. So we've got lots of available models to us. And this has been made available through all the research that's been done within academia and bringing a lot of this capability for us to use. Okay, so the machine learning process itself, there's a lot of tools, of processes, of frameworks, of languages that are currently out there that help us take our machine learning idea into a production-ready system. And this slide highlights the tiniest subset of available technologies that there are out there. But the point of this slide is to highlight that we're still in the early stages of machine learning in a production environment. So we're still at the nascent stages. This area is evolving at a fast pace. However, one of the challenges is taking all these different processes and integrating them together in order to produce a fully a system that is production ready, an ML production system at the end of the process. So that's what we're going to touch upon today. So this is diversion number one of the talk today. So machine learning, whenever I talk to people about machine learning, and often what we hear about machine learning, there's a tremendous amount of focus placed on the models that's driving this area. So we'll hear about the latest and greatest, for example, Google BERT language model, how big it is and how much it's been trained on and what it can be used on. OpenAI's GLP-3 model, how that's being used and so on. We'll also hear about areas such as DeepMind's AlphaGo system, which was trained to play the game Go and outperformed the Go champion. And we'll hear about how it's got a deep learning neural network in the background and a really advanced tree classification structure for searching as well. And that's really interesting. However, if you look at the very famous diagram here by Scully et al. So Google Research a couple of years ago highlighted on the left-hand side here that machine learning models are only a tiny component of the whole machine learning system. And that there's lots of other components that need to be addressed and taken into consideration as well. Yet all the glory and the light is shone upon this little black box in the middle. What I really like about the image on the right-hand side is that in the Scully's paper where they focused on the hidden technical debt of machine learning, everything's composed into nice little boxes, and there seems to be distinction between each of the different steps, whereas in reality and from experience, we know that this isn't often the case, and it's still quite messy at times, and a lot of these different components bleed into to one another. And really what this is trying to show is that there's a lot to take into consideration whenever you are using machine learning to solve a particular problem, and all the infrastructure that's in scaffolding that's required around it in order to get it into production. And at this point, I would say, even though my job is to head up the machine learning team at Detactics, if you can solve your problem without using machine learning, please do. It will save you a lot of headache in trying to get these models into production. And as we show in the next slide, the journey doesn't end over there whenever they're in production. So we're back into an ideal world again, where everything's divided into little boxes here, and this is a typical machine learning pipeline. I don't know if there's a typical one just yet, but we're trying to head that direction, and it's broken up into different components here. So at the start, you've got your data pipeline, and to me, this is the most important part of your project, is your data. So it's this stage where you're collating your data together, you are labeling your data set, you are performing feature engineering, all these tasks to construct a data set before it's fed into a machine learning model to learn from. And this is something I'll be coming back to later. So you're happy, you've got your data pipeline set up, you've constructed your data set, and that's fed into your machine learning model. So you build your model, you train your model. You might have a couple of models that you're training and testing against at the one time to see what the best candidate model is. And you often use a model management store to record information on the different experiments that you have performed, and a model registry to version the models that you have developed. So we use MLflow for this. We also develop in Python, and provide an example of one of the NLP models that we use, which is fast text. Does anybody use these type of technologies currently out in industry? Yeah. I'll talk to you later. So once you're happy with your model, you verify it, you put it into pre-production, it kicks in your testing build stages that you would have in a traditional software development project, and then you deploy your model into production. We use Docker for this, and once your model is in production, then you monitor that model, because this is really where the fun begins, once your model is in production. So for example, we use Grafana and Prometheus just to keep a wee eye on the performance of what our models are doing. And this is to look at things such as data drift or concept drift. So the data that your model's making predictions on, is it still similar to the data in which the model was trained on? We also use a human-in-the-loop approach, so we will be getting feedback from subject matter experts on the predictions made by our models. And you often then have to go back and retrain your model, and off goes the process again. So if I had time for another divergence, I would focus on the monitoring side, that once your model's in production, as this is a very important component of your workflow. But I'm going to focus on data quality instead. So this is the second divergence of the talk. So we've discussed that whenever we talk about machine learning, we focus heavily on models, and it's not just me who thinks this. We've got another paper here from Google Research. I'm not getting any money or paid by Google Research. I know I've used a couple of their papers so far. And I really, really like the title of this paper. Everybody wants to do the model work and not the data work. And it's a really important point of this paper. It's where it goes in and it shows the impact of poor data practices, viewing data as grunt work or unglamorous work, and the impact that has on high-stake applications, such as in healthcare. For example, if you have a poorly collated data set or a poorly labelled data set, and you feed that into a model, and that's used in healthcare, and that's used, for example, in suggesting treatments for a cancer or diagnosing if you have a cancer or not. This has real implications on people and what they're prescribed and their treatment. And the paper also highlights other areas such as the availability of loans and being able to avail of loans and so on. And it highlights the impact that poor data quality has to people at the end of the process, especially in these high stakes domain. So it's just not me and Google Research who think this as well. There's a growing momentum in the area, and one of the champions of this is Andrew Ng, who was Chief Scientific Officer of Baidu, set up Coursera. Google Brain was involved in that as well. And it's a movement to move from a model-centric view of AI to a data-centric view of AI. And this second picture here shows the new startup that Andrew has started up called Landing.ai. And that is a real call for having a systematic engineering approach to data and managing your data, and the impact that will have on the outcomes and the predictions of your models. And there's some really nice examples provided here as well, where it shows that you can twiddle and twist and work away with parameters of a model, and it's only going to push the needle on the performance only so far. However, if you go back and you clean up your data and you improve the labels of your data set, that's going to have much more of a significant impact on your model and its predictions than the parameters will have. Okay, so I covered a lot there in terms of the processing around machine learning. I'm now going to highlight how we have implemented machine has into our platform and what we use it for. And Gartner recently has done some research on the area of data quality and matching and where it's going. And it's highlighted the need to augment traditional data quality and matching processes with machine learning. And the focus really here is to improve efficiencies in process and to have other approaches to, for example, matching and data quality. And this is the approach that we use at Detactics, is to not throw out what we already have, but instead take a closer look as to how we can augment processes and improve processes with machine learning. So I've talked about what we do in terms of data quality and matching. Often clients will come to us and say, okay, here's my data. Could you figure out what data quality rules I should be firing against this? Could you find out, is there any relationships between this data? Can you tell me what's wrong with this data? And while you're at it, can you fix that data? And where's this new data button that I can just press that does it all for me? So unfortunately, we have to tell them, no, we're not quite there yet. But it's a goal. It's a goal to aim for. And this is where we see machine learning playing a role in getting to that end destination of the do data button. Okay, so just going to highlight our machine learning approach. So we augment our pipeline, our processes with machine learning, and we really focus on areas on, right, where can we improve manual processes? So where do we see areas where the same thing is being performed over and over again? It's really quite boring work. How can we improve that for our clients? So that's one of the rationales for using it. And secondly, is there a way that we can add to our tool set of functionality as well? So areas that we've looked at is in matching. It's also in the profiling of data. So getting close to looking at data, looking at the different constitutions of the data and suggesting data quality rules that could be applied to that data based on what we've seen before. And also identifying, for example, outliers or potential errors within that data. We're a data quality company, so constructing data sets is very important to us. So focusing on engineering of data, labeling of data, making the labeling of data a less painful process. I don't know, has anybody in this room ever had to label a data set for, yeah. It's soul destroying work, yeah. So we've had to play around with using things like active learning and so on to reduce the pain of labeling a data set. And again, similar to what I was talking about earlier, you never really hear about that side of it. You only hear about of the swanky new neural network that's out there at the moment. And then working on things like learning from our data to help improve remediation processes. So I'm going to try to do a demo of some of these now. So fingers crossed that the video works for this. If not, not to worry. So first up is rule suggestion and outlier detection. So this is us where we take a client's data set. We have a rule library that we have constructed at the back here. And this has been the most important part of this project, is the curation of a data quality rule library. And where we use ML here is to match the input data to tags and eventually rules within our rule library. So automating that process from here's your data set to here's data quality rules that you can apply against that. Do you want to use these? Yes or no? Because this is often a time-consuming process. And the second area is in outlier detection here as well. So augmenting traditional approaches with other statistical approaches to identify errors within your data. What's really interesting is that there's no one approach that's going to find all your errors within your data. So that's why we need to use a scatter approach in order to do this. So here goes. I'm going to see if I can press play here. Is it playing? No? Oh, super, so it's playing. So this is an example of us which is showing where we have augmented our traditional process of identifying outliers in data with newer statistical approaches. I've got 5 minutes left, so I'm going to swing on to another one because I want to show you another one, which is matching with natural language processing. And I think this example shows how you can augment a traditional matching approach with an ML approach and also networks as well. So this example here shows the matching of entities. So for example, you're a financial institution and you're onboarding a client and you want to make sure that they're not on a sanctions list. So you match them against different sanctions lists. So this approach shows the fuzzy matching of their names against sanctions lists and also the use of natural language processing as well. And we've thrown in graph network analysis to highlight the links and the strengths against the different matches that we have found. And I'm going to try another video here just whilst we're on a roll. So this video here, this shows this matching in process. So you type in the name of somebody here up at the top. We have 4 or 5 different sanctions lists that they're matched against. You've got your traditional fuzzy match score augmented with a natural language processing score. We used fast text and we used cosine similarity to measure the similarities or differences between names, and then we can present it visually in terms of explaining why this match was made and how they are linked to one another. So that was a very quick overview. I didn't think I'd get the 2 done, but excellent. Oops. So I'll finish up there and ask if there's any questions.
No. All right.
Oh, that's excellent. Yeah.
Thank you very much, Fiona.
Thanks very much.